Hey there guys, and welcome back to more of this animation stream that we've been doing. So, last time we had this bug inside the render function, which was throwing errors. Yesterday, that was yesterday, right? Yeah, yesterday. I went ahead and looked into it, could not reproduce it with any other stuff, so that gave me a tip off that it was definitely something in the code. So I went through Sprite because I figured, okay, Sprite might be doing something, couldn't find anything. Added in some more debug code, which I've already removed, so you're not going to see it, but found out that this sprite.location after the first time started reading X, Y, and then 3232, which would be the size of the sprite. And my takeaway from that was that, and it's one of those things I could have checked the source code just to check, but Pillow, since it accepts either 2 or 4 value tuples or lists for the location, the 4 tuple would be a bounding box and the 2 tuple would be top left. So I give it a top left, which is sprite location, and what it appears to have been doing was taking that top left and adding the sprite width and height to the top left corner to get the bounding box, and that's how it adjusts between the two. Problem is that Python and many other languages, but specifically we're using Python, that list that I passed in is an object in memory, and I have referenced that object in memory in my sprite, and then the Pillow code, and again this is apparent, it appears to do this, I'm assuming it makes sense that, you know, this is the explanation here, which is why I haven't bothered double checking what I'm saying here, but it appears that the code then modifies that object, that list object at that location, that memory location, to include the extra values, which then get updated to my sprite. So my sprite.location goes from being 00 to being 003232 in this example, because we're starting in the top left for our sample.py. I then come into here in sample.py and I move us down a step length in the X direction, and now we have our sprite.location being 0, step length, which step length was 1/4 of the canvas size, so that's like not 250, 125. So it moves down 125, let's say. I actually don't think that's right. I think, no, I guess, let me look here. Canvas size, yeah, that should be step length right there. Anyway, point being is that it goes from 003232, which is valid for the top left corner, to 0, let's say 125, 3232. And that 0, 125, 3232 is not a proper bounding box, which is why it comes up with an error, because it tries to put that in as a bounding box instead of the top left corner, and that is where our error was coming from. So we come back over here and you can see what I just did is I just made a copy of sprite.location. The Pillow function can go ahead and have its own copy of the thing and do whatever it wants with it. I don't care, and it will not mess up our sprite.location. So that solved the problem, and here's what we did last time. I don't have a good way of resetting this. I could have swore at one point I saw like forward backwards up here to control the GIF, but it's not popping up right now. So there we go. We have a very short move down 4 times animation. And that gets us caught up with everything that's happened since. So, things we need to implement. Right now, again, we're sample.py. I'm moving down and adjusting the location by myself. Again, this should be handled by the engine and not by the user in theory. The one thing that, if I recall correctly, I was just arguing is that the canvas is the engine in the GIF specific situation, because it's not taking user input. It is just generating a GIF based off of input by a scripter, so to say. Now, there's things we can do to get around that. So, for example, well, I shouldn't even say things to get around it. It's not things to get around it. It's we can make adjustments to make this easier. We can implement features to make this easier, etc. So, and sorry, my throat's a little. I am in fact eating ice cream, and like I was last time, and it evidently is it's mint chocolate chip. The chocolate evidently is getting in my throat a little bit and make me kind of feel a little congested. So we're gonna finish this off really quick so that I do not have this problem anymore, and then we will really quick get back to coding. Alright, ice cream is done. A little bit of coffee, a little bit of water to wash everything down. Alrighty. So, we want to simplify this, right? This movement thing, so that when we write scripts for this GIF module, we don't have to constantly be keeping track of where the location is and what it's doing. So, ways to handle that. Right now, canvas and sprite are kind of linear, parallels, rather, is the word I'm looking for. They're kind of running in parallel. The sprite doesn't really interfere and interact with the canvas doesn't really interact with the sprite, so to say. They just kind of have a reference to the sprite doesn't even have a reference to the canvas has a reference to the sprite, self.sprites, and that's the limit of it. This canvas is not directly controlling the sprite at all, and again, that would normally be, for example, a game engine or some other background thing, but what I'm getting at here is it I hesitate to do this because it doesn't seem quite right to me, and we have this random typing in here. But what we can do is we can make a subclass of sprite if we wanted to. Actually, you know what? Yeah, I was gonna say inside of the GIF class. The alternative is, yeah, you know what? I like the alternative better. So first option was, class, canvas sprite, and etc. Do stuff to make the sprite move on the canvas, etc., etc., etc. Use the random, ignore the random terminal that I just popped up there accidentally because hotkeys. Alternative is instead to have a define move sprite command in here, which I kind of like better, and this will there's a number of ways actually that we can do this. So let's see. Okay, so I'm thinking we can go ahead and add a function to sprite, and class method. I'm gonna make this a class method, that way it can be called, because basically this is a method that is going to be completely agnostic. That's why I'm making it a class method. And determine direction is what I am going to use here, and then we can do class, and offset is what I'm going to call this. This offset is going to be a tuple, and that is in theory going to be an XY tuple. And what this function is going to do is, given an offset from, and ignore from, given an offset, determine the direction in which the offset lies. Now, when we extend this class, if we extend this class to, for example, do, instead of just cardinal directions for directional movement, if we wanted to include 8 directional movement, then we can actually overwrite this in a subclass to, or not even, let's see. So there's a bunch of different ways, right? We can either overwrite it in a subclass, or we could write into here some method for determining direction, referencing another method that then gets overwritten. So, for example, calculate direction, class.calculate direction, let's say, offset. Do something like this, and then down here, class method, define calculate direction offset, class offset, and each subclass would modify this instead. That way, determine direction is always available. It is always, I should say, determine direction never changes. Instead, calculate direction, so the direct call never changes, but calculate direction might have additional information in it or whatnot. That's a little bit overkill. I don't think that's really necessary. I'm just bringing it up as an option. So we are going to just, for the time being, if we need to change this to from a four directional to 8 directional thing, we will just update this code here on the subclass. So, basically, we're going to have an offset, an XY offset, and for example cases, if we have X is 0, Y is 1, then that is going to be up. If we have X is 1, Y is 0, that's going to be right, because we're moving positive X. So that's how we're going to determine it. Now the situation comes in, for example, X plus 3, Y minus 1, right? So that is technically diagonal to some degree, right? However, we only have a 4-directional sprite right now, and therefore we got to determine what movement what direction that actually is. And this comes into more, this is less important for right now, the way that we're setting our canvas up right now, and more important for pathfinding in the future, if we want to do pathfinding. Because pathfinding, you got to make a decision if you have open space and multiple directions that are available, which direction actually move. So, in that situation, we will go ahead and code for that situation. Obviously, you got to go right more than you got to go down. So, in that case, we would go right first. We would just return right. And future calls to determine direction, that offset would go from +3 minus 1 to +2 minus 1, and then +1 minus 1, at which point we can make a determination in our code whether or not we want to prioritize moving horizontally or vertically. I frankly just feel horizontally. That's just a personal opinion. I don't know that there's anything right or wrong. So in that case, in the +1 minus 1 situation, we would move right instead of moving up, assuming that 0 is top left. If 0 is top left, then Y negative is up. So that is the basic rundown of how this is going to function. So we'll just code that up really quick. Let's see. If let's see. Yeah, okay. This is how we're gonna do it. If abs, so absolute value, because we can have positive and negatives, but those are actually equal values. A -1 is equal to a +1 because it's relative to 0. It's the distance from 0. So, 0, 0 being our current square. If absolute 0, abs, offset 0, and again, we're doing XY coordinates, not YX coordinates, is greater than or equal to abs, offset 1, if, and here's the other thing. The other potential, well, it really won't come up, to be absolutely honest, in our situation. But rather than hard coding this next part, we could have a lookup deck. So we could have cardinal offsets equals up would be -1, down would be +1, right +1, left -1. So we could have this, and there's actually a number of ways we can do this. For example, we could do we could zero out these numbers. We could simplify these numbers down to 1 basically, so that instead of having +3 -1, we have +1 0. We could do something like that, and then in this lookup up here, that would be +1 0 right here. This one would be 0 +1, etc., etc., etc. That may be something worth implementing in the future, but again, that's not going to be really relevant right now. And furthermore, I should note that I have up, down, left, right here. This is one of those deals where, technically speaking, we would go like this, right? Because we have a number and we're going to look up the reverse of it. So this is one way that we could do it. Again, this cardinal offsets thing, I am going to leave this up here just for right now. Untouched, I should say. Untouched for right now, and actually hard code it. We may come back to that later because it is useful, but it's a little bit overkill for the moment. So right now we have determined that we are moving horizontally because offset 0 is greater than or equal to offset of 1. So if offset 0 is greater than, actually, one last case that I did not address, and that is if offset 0, or if, I'm going to do if not offset 0, no, alright, we'll be a little bit more Pythonic here. If not, or if offset 0 equals 0, and offset 1 equals 0, return. So this can return none. Otherwise, it should return a string. And one of those things, again, there's better ways of typing this, doing the typecast, not typecasting, type hinting up here. Not particularly concerned about it right now. So, if offset 0 is greater than 0, yeah, return right, return left, and we don't need else here. If offset 1 is greater than 0, return down, return up. There we go. So, very simple thing there. So that is a way to determine direction. And actually, I will do this. Yeah. For future use, it is actually useful. So up would be 0 -1 to have this in here, because we can take this direction and convert it to an offset. So we can go the reverse direction with this. Right, +1 0, put the plus in there. One of those things, plus is technically extraneous, but it is okay to have in there just for clarity. There we go. So now we can actually take also the determined direction from here, the up, down, left, right, and plug it into cardinal offsets to get an actual offset value. So move sprite, and here we can have again this function is taking the sprite, issuing a movement command to it, so sprite.move, and then on top of that it is also offsetting the sprite's location. That's the purpose of this. So let me go ahead and get that all typed up. Animates and updates the sprite's location given the provided movement, or based on, I guess, the provided movement. Based on, and we are going to accept a string here. So direction string. We could also accept an offset. That may be something we decide to add later, but we will look at that and we will cross that road when we get there. So one of these things, we have this cardinal in here. This cardinal can look up into this offset to make sure that we have, and therefore this direction string should match one of our cardinal directions. So first off, we will go ahead and we also actually, I take that back, we also need a sprite. The given sprite, actually no, back up here, grammar animates the given sprite and updates its location. Cool. And this sprite is a sprite. Do we have sprite imported? We do not have a sprite imported. Again, a little hesitant to this, but it is going to make our life easier. And only hesitant because when you import sprite, when you don't have, when you avoid as much as possible circular references, that generally makes life easier for everybody. And actually, I just realized my fan's still moving, so give me half a second. There we go. Not sure how that was coming through on the microphone, whether or not that was messing with the mic. So anyway, this introduces the potential for circular imports. In theory, if we had game engine, and I know I keep on coming back to this, but if we had engine, and I shouldn't say game engine because it could just be an engine for animation, whatnot. If we had an engine, then the engine would bring in both the canvas and the sprite and handle this part, this move sprite itself, and therefore we wouldn't have to worry about any circular imports, because in theory canvas can handle all its stuff without referencing the sprite, or without referencing the engine, anything on the engine, and sprite can handle all its stuff without referencing anything on the engine or the canvas. So then we wouldn't have any issues, basically. Bottom line being, as I said. And this is going to be sprite.sprite. And now we can go ahead and sprite.move direction offset equals sprite dot. Actually, we can even go ahead and make that a function too. Again, we could just do sprite dot cardinal offsets, and it's one of, whoops, Control Z. A reason not to do that is because other classes may not call this cardinal offsets. So determine direction is perhaps a better way of doing that, although that does not actually make sense. I take that back, because that does not give us an offset. So we will go ahead now and make class method define determine offset, class offset direction rather, and this will return a tuple, and this is a string, and down here we can do class dot valid direction, and then return cardinal, class dot cardinal offsets direction. And again, other classes can replace this method with whatever is necessary, or in this specific situation, other classes can overwrite this cardinal offsets and update that so that it returns what is required. So 2 different ways on this situation to handle that one. Direction to an offset. And back over here in GIF, now that we have the offset, so sprite.get, or what do we just call that? Determine offset. And you will notice actually that my typing right here is for sprite, and obviously this determine offset is not a method of sprite. There are 2 arguments here. One is that these things, valid direction, and determine offset, is probably legitimately something that every single last sprite would have, and therefore I can go ahead and copy these up here, and I think I will. So I do think that is a valued argument. And what I'm going to do here, because obviously Sprite does not have cardinals, that doesn't make sense for it, I'm going to go ahead and raise not implemented errors. Because again, the Sprite class, I don't know that it'd necessarily be wrong to create a sprite object, which is just self.location. Again, this sprite object cannot set anything. It has no inputs. Everything would have to be set manually. Technically speaking, you can do that, and there may be situations in which it makes sense to do that. However, for the time being, I'm going to assume that this is just more of an abstract base class than an actual base class, and therefore these methods should be overridden. And this is actually subclass, not superclass. Has not implemented valid direction. And we'll just do that for all these. And that is determine direction, direction, and a determine offset. There we go. And not sample, we want GIF. So determine offset, and you can see now my what do you call it? My linter here now understands what we're doing, because that determine offset has been implemented in the class that it expects, which is sprite.sprite. Or a parent thereof. So, direction. And now for this offset, what we can do is sprite.location. And actually, it's one of those things, there's a couple different ways to do this. As always, 1.5 ways to skin a cat. I'm going to do this the more explicit way, which is this. Sprite.location 0 plus equal, or times equals, plus shoot me. My brain totally farted on that one, and for some reason it was not working. Offset 0 times self dot step length. Step length? It is step length, yeah. And just not completing it for me. And that should be 0. And this now gets 1s. So, for example, if we're moving right, if this offset is right, it is going to be, or if the direction is right, the offset is going to be +1, 0. So, sprite location 0. Let's say we're at 0, 0 right now. So 0, 0 will be 0 plus offset 0, which would be +1 times step length. So that would be, let's say, 32. So 32 plus 0 is 32. And then 0 plus, this is going to be a 0 because it's +0 plus 1 for our offset, times step length. So 0 times anything is 0, plus 0 is 0. So we move right, which takes us from 0, 0 to 32, 0, which is what we expect if we're moving right and our step length is 32. And that completes the implementation of this, so we can hop back over to sample. And for I in range, I probably should have left this up here, but we can retype it. It's not that big of a deal. Canvas dot move sprite, and right now in this script we're using underscores, so I should probably be consistent. So let me fix that really quick. Move sprite, me, and direction we'll do down. So this should result, actually let's do right. I'm going to do right because right now I have this map.gif saved, so I want to make sure that changes. So right now it's moving down. I want to make sure that changes to move right. So let's hop back over to this guy and Python sample.py. Completed without errors. That is good. And I just lost it. Whoops. I can see you guys still see it, but it is actually gone off my monitor and it is not in my taskbar. No, it is in my taskbar. It is just not. It is just not real. Let me alt control delete really quick, see if I can't force it to foreground really quick. Because otherwise I can't minimize it. Where are you? Task manager, where did you put PowerShell? There's PowerShell. PowerShell. Bring to front. Okay, did not work. Minimize. Okay, minimized work. Bring to front. Yeah, it is still off the edge of my screen. I can see it minimizing and maximizing off the edge of my screen, but hotkeys to move it around the window is not working. Windows key and direction key for the record, in case you're not familiar. So those are not working, so I'm just going to kill it, and I'll open it back up in a second. Otherwise, I want to check this map.gif, and as we can see, our character is not moving. Excellent. Excellent. So let us go ahead and we're going to hop in here and print a me.location to make sure that our character is actually changing locations, and we will go ahead and do me.frame because that should also be implementing. And actually, while we're at it, me dot and current direction is the word I'm looking for. There we go. So now I gotta get PowerShell back up because it deaded. There's my window. Open PowerShell window here. Did you get that back or no? Okay, it looks like you got it back on your screen. Good, good. .m scripts activate and up to. Alright, so it does look like we're moving. That is good. Oh. Yeah, there we go. There we go. I have realized what it is. We have not done create frame. And I will not go and put these two together, because when we get more sprites on the frame and more sprites moving around, we want to be able to move them all before creating the frame. However, I have thought of the next thing that we're going to do. There's a bunch that I wanted to get done, but the next one will be pretty interesting, and I'm actually going to go ahead and implement that next. But let us just look up here at map.git. Oh, I haven't run it again yet. Run it again, and in the background you should have just saw, let me minimize this, our guy changes direction and moves to the right, working exactly as expected. Now, the fun thing to implement, and I like implementing these things, and that is enter and exit. Self, and I'm going to go ahead and leave it like that. And divine exit self errors pass and pass. And now, all right, so enter and exit. Enter and exit is the with context. That is what it implements. So what that allows us to do is, we'll hop back over here to sample. For I in range 4 with canvas, we can say, put this in here, and now we can go ahead and move this down to here, and this code right here, self dot create frame. So when we enter this context, when we exit the context, it creates a frame. So when we enter it, we're basically saying everything that happens within this context, we're going to implement it, and then at the very end, we're going to go ahead and create a frame. Now, right now, that doesn't really interfere with anything. There are situations where this either would be more beneficial or less beneficial, or possibly detrimental, depending on what we're doing inside the context, because of errors. So right now I'm not checking for errors. As you can see, I'm not doing anything with the errors on the exit. Exceptions, I should say. Whoops, let me just change that. So I'm not doing anything with the exceptions right now. There are different ways you can handle that. Right now I'm ignoring the exceptions, and it will always create the frame no matter what, but there are situations in which you would want to handle the exceptions, for example. So basically, I've heard mixed things. I've heard exit functions should not handle exceptions, which is alright. That's reasonable. I actually kind of agree with that one. However, what you could do is you could unload all the movements that had happened, every single action that had happened since the enter. You could undo those before the higher script gets a chance to handle the exception. And that would probably be the best thing to do, the best way to handle that. Right now, we do not have anything like that going on. We do not have a history. I talked about this last time. We did not implement any kind of history navigation. If we had history navigation, then that would actually be very useful right now. So we could start up a history queue right here, and then on the exit, if we have errors, we can undo the history queue. And again, the history queue I was talking about is using canvas.state. Now, the next thing to talk about in this is with canvas.movesprite. This is not intuitive right here. What this probably should be, sorry, just grabbing drink coffee really quick. This would make more sense. It would be more Pythonic, I'm going to say. And I've thrown that term around quite a bit. But basically, it would be clearer to be something like with canvas.frame. Or, again, if we had our history thing implemented, this would definitely be a situation where, or we would definitely use that state. We could do with canvas.state, and that would convey the idea that we are entering a state of the canvas, and on the exit of the canvas, we can go ahead and create the frame based on that state. So for right now, because we don't actually have a state, I will go ahead and just call this with canvas.frame, because that is more clear in this situation, because we don't have any state situation set up, that we are entering a frame, and that frame will be resolved at the exit. So in order to do that, though, if we come back over here, you'll see this is only with canvas. This is the only thing that we get with that. In order to get a frame object, we're going to have to actually create that. And this does not need to be, for the record, this does not need to be named frame. Frame equals frame. Technically speaking, yeah, that is correct. This does have to be up here. This is one way to implement this. There's actually a couple different ways, but this is one way that we can implement this. So what will happen here is this, whoops, wrong page, this one. So it will get a reference to canvas.frame, okay? Now, if this frame ever gets replaced, so this canvas is an instance, if somebody goes and does canvas.frame equals my frame, and that frame does not have enter exit on it, that will cause a problem. So people shouldn't do that, but just for the record, that will cause a problem. Otherwise, it will come up here, it will get a reference to frame, and I am going to have to make this class method, because this is not going to be we're not initializing a new instance of a frame each and every time. Now, again, if frame became a state, a canvas state, then we could absolutely do that. And how that would look in that situation is we could do canvas.frame, let's say, and down here we'd have define frame self and return frame, and you probably want to do frame self. That way the frame has a reference back to the object. So at this point, this would be define init self canvas self.canvas equals canvas, and then these no longer have to be class methods. These can be regular old bound methods, and self.canvas.create frame. So that's how you would implement it, like that. And it's one of those things I can either hit Control-Z a whole bunch right now, or just leave it as is. And frankly, I do not see a problem with leaving it as is at the moment, so I actually will leave it at like that. So this, again, just for the reference, just in case you're not following, we're calling canvas.frame. Canvas.frame returns a reference to a frame, a new initialized frame gets created, and it returns that memory object, that frame, back to us. Then the rest of this with clause resolves, and this says with that frame instance that we just created, and then does all this. So again, I just want to be clear, that's how that enter and exit context works in this situation, because we're actually creating a new instance. So let us go ahead and make sure that works. So we'll step through, and on each increment we'll create a new frame instance, which we will then enter. We will then enter the context of that frame. Inside of the context of that frame, we will go ahead and do canvas.moveSpriteMe, right? And then we will exit that context of that frame, and on the exit of that context, the frame will call self.canvas, right? We save that, .create frame. And create frame, obviously, as you know, adds a frame to adds a rendered frame, I should say, to its list. And that is all that explained in very simple terms. So let's change this to left, just so that we I take it back. Left is not going to work because left can work. We can make left work. Let us go ahead and, do I have sprite location set yet? I do not. Now, this is actually a good instance. We're going to come back to that. I take it back, okay? And sprite. Does sprite have... No, sprite does not come with a set location button. Or, button, yes. A sprite location button. It does not come with a sprite location initialization argument parameter. Parameter is the word I'm looking for. So for right now, we're going to do me.location equals let's do 0. No, 500 minus 32, 0. So this, and actually sprite size. Now I don't have to explain this one. Canvas 0 minus sprite size. There we go. Now this should be clear what exactly I'm doing right here. So I don't have to explain that. And now we can move left. So let's go ahead. That is saved. Bring up the PowerShell once again. Run it. Minimize it. And hit map. And there we go. We can see ourselves running from the right hand side now. Excellent. Excellent. All right. The one thing, what was the thing I just thought of? Oh, okay. So at this point, obviously you saw the situation where I have to do me.location here, right? Instead, obviously that's going to come up a lot. So if I have 100 sprites that I need to add to the canvas, I don't want to have to do sprite and then sprite.location equals. That is going to be obnoxious. So we will add that as an argument to canvas.addSprite. That makes sense. That is a situation that makes sense. So that is actually on canvas base, it looks like, which is cool. That's fine. I'm completely okay with that. Init canvases, add sprite, location equals none. And I'm actually not going to type this one. Well, I mean, type any, right? And I think that's technically not correct. I think this should be like typing.any or something like that. But regardless, it works for me. It's one of those things. Python is not actually type strict, so we can handle that this way. So we can just use that any, and everybody will understand what we're trying to say. So regardless. If location is not none. And this is one of those things, I think I read that we do have sentinels in the newest version of Python, sentinels being basically constant values. So, and there may even be a constant value for null at this point. I'm not 100% sure on that one, which would otherwise be parameter not provided. There are also other ways we can handle that. For example, we can go ahead and bring in inspect the parameters if we want to that have been provided and see whether or not the parameter wasn't provided. That is obviously really overkill and not worth doing. So right now we're just going to do if location is not none. if I cannot see a sprite location being equal to none explicitly. Actually, you know what? We can even solve this in additional way. So back over here on sprite, we have this location 00. Technically speaking, that is bad. Technically speaking, that is bad because that assumes a 2-coordinate system, which again we may not actually have in a subclass. So we're setting the default for the sprite to 00, which may not be valid for the subclass. So it is better to set this as none anyway. And if the user tried to provide add sprite, comma, location equals none, if that's what the scripter, the user, attempted to write, then this actually makes no difference in theory. Actually, no, it does. But my point being is that we don't really need this check anymore, so long as we assume that none is a valid location. And if none is not a valid location for a subclass, then the subclass should check for none itself. However, I can see, and the reason why I changed, other reason I changed that 00 to none, I could see a sprite not being visible on the screen, which is something I considered bringing up in earlier stream, in last stream. Sprite not being visible on the screen could be represented a number of ways. It could be represented by a negative number in a situation in which the canvas is 00 top left corner. Then you could do -1000 or something like that to get it off screen. Or you could have sprite.none or sprite.location equals none. That's the other way to change or to signify sprite not visible. It's an option. It's one of those things. It depends what you want to do, but we can go ahead and run with this. Now, the one thing this does do, by me just doing sprite.location equals location, if the user does not set sprite.location explicitly, now it will automatically default to not on the screen. Which, one of those things, it's just something that has to be documented. It's not necessarily good or bad, and it has its uses, as I've already outlined. So, we are going to go ahead and come in here. Come in. Where do we want to come in? I wanted to come over here, actually. And on the render, so basically, let me just look before I actually make this comment. Okay. This is the only thing I see so far that actually determines that this is a two-dimensional canvas. Now, it may be wrong of me to have this smooth sprite thing right here with the hard programmed two-dimensional canvas. And we can... We you know what? For the sake of completeness, meh. It's one of those things. Back to last stream, I kept on saying I'm going to try not to overcomplicate things, and I'm going to leave them simple. Yeah, alright. So, we are going to go ahead and make this agnostic right here, just for the sake of being agnostic. So, sprite.location will now be well, let me write it this way just so that you can follow my mindset. Okay, so we're going to have the sprite location, which I'm going to call loc, and we're going to have the offset, which I'm going to call offs, and we can pair those together piecemeal. So we can do that in zip sprite.location and offset. So now these are paired up 1 to 1. Sprite location 0 to offset 0, sprite location 1, offset 1. And now at this point, no matter how many of these there are, we can, and I'm going to go ahead and throw these parentheses in just for clarity's sake. We can do loc plus off times step length, step length. And then obviously this is for, because this is a list comprehension. So we have now gone ahead and made this agnostic. Was that completely necessary at this point in time? No. But it is now technically agnostic. So if this is a three-dimensional graph, and by graph I mean canvas, and then in this case we will have x location plus x offset times step length, y location plus y offset times step length, and z location times plus offset, etc., etc., etc. And that works for 4 dimensions and 5 dimensions, and etc., etc., etc. Not that we're ever going to make a 5-dimensional map, but point being, this now works no matter what the size is, so long as sprite location and offset are the same size. We could type check that, or not type check it, but we could put a validation check in there. I'm not going to bother. Again, I've already overcomplicated this as is. Okay, now that was all brought up by setting the location of the sprite. That's what it was brought up by. So in the add sprite, which was in the canvases init, we have this location any equals none. And oh, actually I take it back. That's right. Recalling my train of thought. Now we're into render was the issue. And again, off screen, I guess we can just determine is none for right now. Again, that may end up location.none being a mistake. I don't foresee it being a mistake, but it could be. So we probably want to keep in the back of our minds that this function, if location equals none ever becomes anything other than sprite invisible, is going to have to be updated. If sprite.location equals none, capital none, continue, not return, continue. So if the sprite is invisible, do not draw the sprite. Very simple right there. The next thing is this, again, if this is three-dimensional, right now this canvas is set up to draw on a two-dimensional canvas. Technically speaking, this paste function right here should be replaced with something else. So if we're drawing a three-dimensional map onto a two-dimensional screen, which is what we're doing, we're on a computer, we're drawing it onto a two-dimensional screen, then transformations are going to have to happen, and those transformations are going to have to be pasted in specific locations based on the transformations and on the perspective, etc., etc., etc. And therefore this will not work correctly, this line right here. However, I've already gone and complicated way too much already this stream, so I'm not going to bother with that right now. That is something for future us to be bothered by. So, let us see. What else do we want to implement? So I should have made a list. The next thing that I can recall wanting to implement is actually just for this, just for the sake of the sample .py, was introducing random, and just implementing random movement. And actually, you know what? This is fine, because there's two different things that were also in my mind to implement. The first was bounding boxes for this canvas, and the second, not bounding boxes, that's the wrong term. Basically, edges of the canvas, taking into account the edges of the canvas so sprites can't move off. And the second thing, well, there's actually 2, 3, 4. There's a bunch of stuff that could be implemented. The second thing immediately is actually moving the screen with the movement of the so more specifically spoken, your Mario type effect, right, where you're running along and the screen moves with you. I'm again blanking, just like last stream, on how you refer to that, but whichever. We will not be implementing that one today. Obviously, I did start this stream a bit later than last time, so we will not be going the full nearly 3 hours that we did last time. But I do want to go ahead and implement some logic somewhere. I know that was extremely precise. Let's see. The question is whether or not to change the canvas class at this point. Okay, so what I think I will do here is refactor some code first, because I do think we will be adding another subclass. This move sprite, and evidently we just brought in sprite in this one. This move sprite should in theory work for any canvas, so I feel comfortable moving that to canvas base. Save, render, create frame. Okay, yeah, all this is good for good for GIF. So over here is where I think I will create the... Actually, I think we'll create a mix-in. That may be the best way to go about this, is to create a mix-in. So a mix-in is not actually a full class itself. It does not get initialized. It adds functionality to an existing class. Now, implementing this, again, trying to future-proof stuff, it may be useful to break up move sprite. And we would break up move sprite into before move and after move, or something to that effect. So before move would determine what the sprite is going to do. So it would do something like sprite.getNextAnimation and determine the offset right here, just like it is doing right now, right with this one. And then it would go ahead and register for the engine. It would register a callback or something to the effect, or an event, something like that, and launch that. And then the engine or whatever would be able to interfere and say, oh, wait a second, you know, modify it in this way. Modify what you're doing in this way. That comes up for this case, which is going to be, you know, how do I want to call this? What do I want to call this? Mix-in / subclass. Single page canvas, I guess. So that would be useful in this situation, because move sprite would get the sprite animation and offset, the offset being the one that we're more concerned about. And single page canvas could go and say, oh, wait a second, you're about to move off the map. Stop. Do not take that action. So that is where that kind of setup would be useful. The question is there a simpler way for us to implement this? And I know I'm being quiet, I'm just thinking. So the answer is that I'm actually probably better off breaking this up like I'm talking about. So let's go ahead and do that. So first thing I'm going to note is this sprite.move obviously cannot be here. The second thing I'm going to note is sprite.move is not part of sprite superclass. Base class, abstract class, what do you want to call that? I think so. Sprites, we can make the argument, and I kind of made this argument last stream, as I recall, that there is potentially a difference between a sprite and a doodad, and not only on functionality but also on how they're displayed on the screen. So I think I am alright going ahead and adding a define move self args coargs and raise not implemented. Error. Subclass has not implemented move. I think at this point I'm going to make the declaration that all sprites, well, all sprites should have move defined at the very least. Move, technically speaking, we could have a subclass of sprite called stationary sprite, and move could return none. You know, that is one way of handling that. So I feel comfortable doing this just to get that taken care of. Now, this part right here, breaking this up. So we can determine, we can assume that offset is accurate, that offset is going to be accurate for the canvas, so we don't have to worry about that. We can always just generate offset no matter what, given direction. Actually, we probably want to do this. I don't know. Originally, I wasn't going to do this, but I think it is probably in the long run useful to give the option to either use direction or use offset. Yeah, I think that is okay, and then we can do both direction and offset. Yeah. Alright, so this is how we're going to do it. First off, canvas base is going to, I guess we'll just do listeners. We're going to keep it easy, I guess. Yeah, it's one of these things. Event loops are a whole entire can of worms, and how exactly you go about implementing event loops, there's several different ways of doing it. The simplest way is to register listeners and then per event call back the listeners in order and have the listener be able to, for example, raise exceptions or return a value such that you can interpret that value as an action to take. So there are, like I said, that is rather the simplest way to do it, the most straightforward way of doing it. Generally speaking, though, when I've implemented event listeners, I've implemented them as their own class object, and I'm wondering whether or not that's not overkill, or if I'm going to regret not doing that in the future, because I normally do that for reasons. I think I am going to go ahead and just use a dict for right now, and we will regret our actions later. Okay, yep, alright. Self.events equals dict movement equals list, rather. And now we need to implement define add listener self event callback. And technically speaking, you could also have something like add here. This would be that's what tkinter refers to it as. I'm blanking on what JavaScript. I'm pretty sure JavaScript also has this, or has an option rather. And basically, there's you could add a functionality here, for example, called add, which, given a certain value, will replace all current events, callbacks. It will just wipe them all and only have the one. I am not going to do that. I am going to leave that off for right now because it only complicates things really. And it is not generally necessary. Generally speaking, you should be able to just say for listener, in listener, etc., remove listener. And that's one way you could wipe all the listeners out if you wanted to do so. So, and I guess I will also Ben guy, is this coding just for animation only? I'm not entirely sure of the question. There is code on the sprite that the sprite handles. Otherwise, everything basically is working, handling whatever it's supposed to be handling. I'm assuming that's music you're hearing. Back over here. Where do I want to put this? I guess up here. Yeah, it's not really... Nah, I guess it's fine to put up here. Nah, I don't really like it up here, but we're going to do it anyway. Basically, we need to value check that we're registered. I guess we don't necessarily need to value check. All right, I take it back. Generally, you would, just because a user... right now, we're just coding for a GIF. That's all we're coding for right now. I am set up with the structure to do real-time animation playback. That will happen eventually, in theory, but for right now, it is just for GIFs. Anyway, as I was saying, what we generally speaking, you want to give the user feedback that a given event is or is not valid, but at the same time, if you never call the event, then that doesn't necessarily matter. So we will go ahead and just allow users to add random events, because it is not technically breaking anything, because we are not going to ourselves call them. So self.events.get event, and we will use that. Actually, that would technically not be correct. Actually, yeah, we can still do this. Listeners equals, and then listeners dot append callback, and self dot events event equals listeners. There we go. And then remove listener. And this is one of those situations, as I said, and this is one of the reasons why I normally would have this on another object, is we're not providing an ID for any of these callbacks. We're just having them as references to objects in memory. And therefore, we technically in Python, this does 100% work. This is not that big of a deal. However, if we, for whatever reason, wanted to register a function multiple times, that would not work. This callback would not work. It would only fire once. It would not fire multiple times. Whereas if we were registering listeners callbacks, if we're registering callbacks with IDs, then we would store the ID and the callback inside of this. This would be, instead of a list, it would be a dictionary. And then we would be able to register the same function multiple times. Again, there's not really a good reason I can come up with to register a callback multiple times, but that would be one benefit of doing it that way. That is also more complicated. So dot events dot get event dot remove callback, and that will remove the also one event in there. So this will look into the events dictionary for the given events. One way or another, it's going to return a list, and then we can call remove on the list to remove callback. I don't know, that's pretty advanced understanding. I mean, I appreciate the compliment, but it's, I mean, coding for, I don't know, something like 16 years, I guess. Well, no, more than that. More than 16 years. Coding seriously for maybe 18 years, 16 years, I don't know. Something in that range. It's just been coding for a very long time. So again, I wouldn't label this specifically as again, I appreciate the compliment. I wouldn't say I have a pretty advanced understanding. I just simply have a lot of understanding, if anything. Just a wide variety of screwing stuff up and then knowing, okay, don't screw stuff up. Okay. All right, yeah. So now single page canvas. This is all right, this is actually going to have to be a subclass at this point instead of a mixin. Yep. Instead of a mixin. I wanted to keep this as a mixin, but in order to register it as an event, which we decided we needed to register as an event for this move sprite, so actually let's back up here and get this resolved really quick. Let us, for callback in self.events movement, callback offset direction. Do I like that order? Yeah, I guess I like that order. And up here, we're gonna have to type check direction and offset. If not direction, or I guess if direction is none, and offset is none, then we are not actually moving the sprite, so we can raise a value error. Do we want that to be a value error, or is that an argument error? No, I guess that's a value error. No, it's an argument error. Or attribute error. No, argument. Oh, I can't spell? No, that should be. Maybe I can't spell. Alright, there we go. Argument error. Much better. Argument error. Direction or offset is needed. If direction and offset, so if these are two actually, I guess I should say, nah, they should be values. They should be non-false values, non-falsy. Yeah, okay. And we will also make this an argument error. I guess, nah, okay, we won't raise this error just yet. We'll go ahead and do d equals sprite dot determine direction offset. And now if d does not equal direction, so if the provided direction it does not actually equal the offset, then we can go ahead and raise this this argument error. Direction and offset do not were provided and do not match. And now, finally, now that we're sure that everything is hunky-dory, if direction and not offset, we can fill in the other value. If offset and not direction equals sprite dot determine direction, offset equals offset. Alright, cool. So now we have offset and direction, and we made sure everything is valid in here. And now we can go ahead and call our callbacks. So any function, right now we do not have any handling for responses from the callback functions. Let's see. At what level? So this is a question of at what level we want to handle any errors. We could do a try and except in here. That is bad, only because we are not confident on what the errors are going to be. The errors could be any number of things. What the other thing we could do, the thing that makes more sense though, is if something wants to, I'll call this response, right? Response equals callback. If the response is none, we can say, actually no, we should not use none just because functions very often return none. So that was a bad example, but if response is false, rather, so if a callback specifically returns false, now we can just bail. This is a way of handling this so that for down here, for a single page canvas, if the response is false, if the single page canvas says, oh wait a second, you can't move off the edge of the page, it can return false, and then we can receive that false here in response and just return. And return will stop us from doing anything else, and we're good. Again, there are other signals we could receive if we wanted to. For example, I don't know, maybe change the animation type or something like that. That's, again, something way more complicated, and that's something actually that would have to come in a subclass. And that is also a reason why we probably we should probably break this up one more time into define, handle, move. And I'm doing this underscore here because this is not a function that should be users should be touching. I'm going to go ahead and do self dot handle move offset direction, or I guess direction offset. and I'll change the other one. And this, the reason I broke this up like this, in case it's not clear, is that this can be overridden by subclasses. So, for example, if the subclass wants to, if we have a multi-page canvas or a scrolling canvas, let's say, and this scrolling canvas wants to say, okay, you can move, but don't animate the sprite moving because we're going to leave the sprite just frozen in time as the canvas shifts to the left. If you can imagine one of those games where you get to the edge of the map, and as you step off the map, everything freezes, the canvas shifts to the side, and now you're on the left-hand side of the canvas, and you've got a new map in front of you, that kind of situation. So that would allow us to do that. And we can come down here and move this up. We could also... I'm just going to say that. So, at this point, rather than handling this response here, actually, yeah. Alright, so there's a bunch of different things here, right? We could break this up into a third step, which is execute move. Self direction offset. So we can do this, and actually we will need to continue moving sprite along so that we keep reference to it. And if handle move gets overridden, handle move should call execute move. The reason I am chaining it like this, sprite direction offset, the reason I'm chaining it like this instead of having this up here is for this kind of situation where we want to return out. So if we return out from here, then that would just bring us back to execute move, and we'd continue executing move. So again, this false here, this return, is supposed to stop us from moving, but then we go and execute move anyway. Whereas in this situation with the execute move down here, this return will actually take us back to here, which then exits the function and takes us back to our main loop, what is effectively our main loop. So that is why I'm chaining it like this. There is, again, other ways of doing this, in which we do have execute move up here, and then we just handle, for example, a response from here, or we raise an exception. That's another possibility. This is the most straightforward way, and that is the reason why I am doing it this way. Let me just go ahead and toss sprite in here, just for reference sake. Direction is string, offset is tuple. And I wanted to fix this guy so that he is uniform, and we should also provide the callbacks with sprite as well, just in case they need it. And I deleted that. This returns none. String, tuple, none. And there we go. Alright, so we now have the infrastructure in place for single page canvas to intercept. Again, the way this is set up right now, we're not initiating, because I was going to have it as a mix-in, it wouldn't initialize single page canvas as an, and therefore would not give it an opportunity to add itself to events. There are the option here, the option if we do not initialize it, is to have a function called define initialize single page. And the benefit of doing this, and let me just clarify here, self dot events movement, or I should say self dot add listener movement self dot check bounds. Okay, the benefit of this is that we could also have detach single page self, and that will unregister self dot remove listener movement self dot check bounds. So this is the benefit that this has right now as a mixin, is that we can actually turn the mixin on and off effectively. Whether or not that is reasonable is honestly up to you, and since I can think of edge cases where that is reasonable, where that is useful, I will go ahead and leave it in, which is the second time I've done that today. The second time I said the last time, just in case we forgot, because OCD, or not OCD, ADHD was up in here in the frame. I said, oh, you could go ahead and do it this way, and then I left it in. So, yeah, this is the second time where I initially thought to myself, I'll take it out. And now I can't think of a good reason to take it out. And it actually serves more purposes in there instead. So we will go ahead and do that. So in this situation, this GIF got GIF got canvas. Yes. This one. Huh. Alright, you know how I say there's 1.5 million ways to skin a cat? There is another way of doing this, and that is to have not just event listeners, but add-ons. So basically, what I'm thinking about right now, and the reason I stopped, is because in our sample.py, I'm going to have to initialize this somehow. And in our gift, I'm going to have to initialize this somehow. And this would, in fact, for every single canvas subclass that we make, we would have to do a class single page canvas base, and single page canvas. We'd have to do this for every single last subclass, and that does not make any sense. So instead, I am going to backtrack on what I said here and turn this back into a subclass, because I cannot think of a good solution otherwise that keeps things simple. So define init, self, super, step, etc. And now we can do self.event, self.add listeners rather, movement, and self.check bounds. So we will be doing this as a subclass. I just said that, didn't I? I just said that. Nah, alright. This does not actually simplify things enough. I am a little all over the place. It is nearly 10, so that would explain that one. Yeah. Should have started earlier. Okay. So, the reason why I am putting this back is because even if I did this, then we'd have to come back over here to gift.py and make another subclass that is subclassed off of, instead of canvas base, single page. So since we're doing that one way or another, we will go ahead and class single page canvas, and single page canvas. And the single page canvas needs to be brought in here. There we go. And pass. We could also, yeah, actually, let's go ahead and do that. So we can bring this in here, and then self dot what was it? Attach, add, what was it? Initialize. I am going to change this from initialize to attach because I'm using detach on the backside. Attach, spelling, late at night, attach, detach, huh? Okay, yeah, late, relatively late at night. I'm sitting here wondering why attach has 2 T's and detach has 1. Oy, oy, oy. Alright, so anyway, this will go ahead and get attach, self dot attach, single page. There we go. Now we can come back over here and finish what we were doing earlier, which was define check bounds. Self, and this callback should have should get sprite, direction, and offset. And actually, we instead of offset, I guess we actually should have final location instead. We could have all 3. We technically could have all 3, but I think that's overkill. So instead, we're gonna have target location, and that is the square that it's going to end up. We can go ahead and do this, target location, and well, let me paste this really quick before I lose it. Target location equals lock off self, etc. Yeah, that should all be right. So target location here, target location here, target location here, and there we go. Because I do think that the offset or the target location is most likely to be more significant than the offset. Update that. And now we can check that target location is within the bounds of the canvas, is what this all boils down to. So if target location 0, I should say that again, this is assuming a 2-dimensional. I'm not entirely sure how we differentiate at the moment, so I'm going to leave this as non-agnostic. This is going to be specifically 2-dimensional. I'm not entirely sure how to go about off the top of my head. Again, it is a bit late. I know I'm going to make that excuse a whole bunch, but it is not coming to me how to make this agnostic off the top of my head, so we are going to just handle this as is. So target location 0 is less than 0, or target location 1 is less than 0, or target location 0. Actually, I shouldn't. One of those things. We can be a little bit more what you call it, a little more efficient. So target location should be between 0 blah 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 blah. Yes. Self dot with self dot size 0. Actually, something just occurred to me. Okay, this 0, the way we're checking these bounds here, I could make this agnostic, right? But it runs into a bit of a problem when 0 is not the top left corner. And the 0 would not be the top left corner, typically speaking, in a 3-dimensional map. And therefore, for that reason, this 0 being greater than target that I got here would be incorrect in that situation. So yeah, the way I'd have to go about this is by determining the having the lower bound. So I'd have to have a full bounding size for the map in units and then modify it from there, which is too much difficulty and therefore we're not going to do. So anyway, back to what we were doing. This again is going to be just specifically 2-dimensional. So 0 being the top left, if target location, or if 0 is greater than target location, that means target location is negative. So that is bad. If target location is greater than self.size, that is also bad because that's outside the scope. So that is one situation, and then the other situation is obviously 0, target 1, etc. Self.size 1. And we will return false. Otherwise, we can do nothing. Otherwise, we can just chill out. So, in the case that the target location is outside of the map, we will go ahead and return false. That response will be false, and then we will return out and not execute move. Otherwise, we will execute the move and everything will be hunky-dory. And I am just double checking here that I didn't mess anything up. I don't believe I did. So, that is that. And we are now at a point where I believe I can do that random stuff. Basically, I am just thinking to myself now whether or not, or how exactly to write this, basically. So we're going to add the sprite. This is still top left corner, or top right corner rather. So I'm just going to get rid of that. And actually, again, location wow, okay. Location is going to have to go back to 0, 0 because none is not correct. We are creating the first frame just as is. Now, for I in range, let's say 20. I am going to, I guess we'll use cardinal directions and we'll use choice. And we are going to just randomly move. I was thinking, what I've been thinking since I came back here is whether or not we want to do anything at the moment with outputting just to see what's happening, to see whenever it decides not to move. And the other thing is that this 20 honestly may not be enough to make sure that our function, our bounding function, is working correctly. Actually, I will go ahead and do that. GIF.single page canvas so that we can actually have our bounding functions so we can't run off the side of the map. Yeah, alright. So 100 should be enough to see whether or not we actually accidentally run off the side of the map. And otherwise, we're just going to move sprite, and this is going to be random.choice and supports length and get item. Huh, that's the first time I've seen that type hint. Interesting. So this will be canvas dot, or no, sprite rather. Sprite dot, sprite2d dot cardinals. There we go. So on each frame for each frame. We're going to move the sprite in a random direction, and we're trusting our single page canvas to keep him in bounds so he doesn't run off the page. So let's go ahead and pull back up. And I had a typing error. Excellent. Excellent, excellent, excellent. There's underscore check bounds. And this is not underscore check bounds. Alright, and it has resolved, and I should minimize that for you guys. Alright, let's see our guy run around. Alright, our guy is running around. He has not run off the edge of the page yet. We had some instances here where he kind of stopped, which kind of feels like he ran against the page. So I think that is what happened, and F5 does not reload the GIF, so let's click off. So as we're watching here, watch for that. So right there. So you see those situations where he kind of stops and tries and doesn't do anything. That, I believe, I'm 90% certain that is a situation where it's trying to go up and it realizes that it can't. So that suggests to me that our very well, first off, that the bounding, that the single page canvas bounds work. That's good. And the second thing is that we've set up random movement. Nice. Now obviously that was very boring random movement. We would want to create some kind of algorithm to make a more interesting random movement, and I will consider doing that next time. Otherwise, we have achieved basically, well, a great number of things that I wanted to achieve. I'm not sure. Again, I should have made a list. At the moment, off the top of my head, I can't think of anything else that I wanted to add to this aside from just getting to the point that we're doing random movement, but there very well may have been something and I just didn't make a list. So anyway, I can say that we have achieved absolutely everything we wanted to get done today, and I am very happy about that. And we did not run into any serious bugs like we did last time. So this has been a great stream. Thank you for everybody who showed up and everybody watching right now. And let's see, tomorrow is Saturday. Normally I do a Saturday morning stream around 10. Unfortunately, I have plans for 10. However, 10 a.m. morning stream. However, those are plans outside, and according to my weather app, it is supposed to be thunderstorming outside at 10 a.m. So those plans may get canceled, and you may see me tomorrow morning at 10 a.m. What we will be doing tomorrow morning at 10 a.m., I'm thinking maybe Mustache. I'm thinking it's one of the things I said I wanted to play Mustache during the week this week, just so I didn't get rusty, and that obviously did not happen. So we'll probably play some Mustache tomorrow and on Sunday, and I'm not entirely sure what other streams I want to do for right now. So again, making a bit more interesting random movement is probably a stream, plus any other things I want to add to this module. So I'll dwell on that. I'll think about that one. And beyond that, the other stuff I wanted to do was to flesh this out a bit more, flesh out my pixel art a bit more. And by flesh out, I mean add stuff. And that's going to have a whole slew of issues with it that I'm going to want to resolve. And whether or not I resolve those on stream or not, I will decide. So yeah, maybe more pixel art streams. We'll see what happens. Anyway, that is everything for me and all the plans moving forward. As always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.